Hey, welcome back. This is going to be a quick update video going over stuff that I've done during the alpha development of the game. It's not going to be a typical video where I set up the green screen and everything, simply because I changed stuff around in my room a little bit. And I have this green screen back here, but the problem is that it's not very flat and it's not going to produce a good key, plus I'm wearing a green shirt and all that stuff. So it's going to be a little bit common. I'll still try to edit some stuff in, make it a little bit fancy for you guys, but it's gonna be a little bit normal, if that makes any sense. So I have GitKraken open. If you don't know what GitKraken is, it is a version control software that uses Git, but displays all the stuff that's in Git. So if you don't know what Git is, that's a interesting question to answer, but effectively it's a way to take your project and store it on a server somewhere else so that you can, one, access it from anywhere, and two, when you create commits, it'll like store a snapshot of what the project used to be before you added the new feature or new code. So if something breaks, you can always just revert back to a previous commit, or move it, changes back, so on and so forth. So I'm just going to quickly go over stuff that is here in GitKraken, just so I can go over what I've been able to do. And so this is just for like the initial commit and all that. So about 2 weeks ago, I got the player camera going. And there's two versions of the player camera, and player camera, it'll go through more changes, but effectively I can demonstrate this pretty quickly. If you'll notice, I have 3 different kinds of cameras. So they all do different things. Oh, sorry. And they're all modular, so I can switch them out and change them out for each other at any time. So what I can do is I can turn this off, and I can just add the player motivated camera, and it'll work just as fine. So the player motivated camera just follows the player, or it's supposed to follow the player. Oh, you would input the player transform to here, I guess. That's fair. So yeah, it's meant to be following a certain follow transform that you give it, and it'll just follow the player. It has its ups and downs. The main downside of this, if you'll notice, if I play it maximized, you'll see whenever it moves, it's got this weird like jitter. Like the player will move and then this thing will move, and it's got like a weird kind of jitter to it. Because I believe, if I'm not mistaken, the camera controller script, the way it functions is essentially it runs on fixed update, because I wanted it to move along with the player. The player's movement is based on rigid bodies, so it uses physics to move. And in Unity, whenever using physics, it's always good to use fixed update instead of just a normal update, because fixed update, the biggest reason is that it's more accurate with physics calculations. So I had the camera run on fixed update as well, but it adds this little interesting kind of like, I don't want to say jitter, but whenever you're changing directions, it's like the player moves first and the camera moves after, which is a very interesting problem to have. But yeah, so that's the player motivated camera. Next up, we have the mouse motivated camera. Yeah, so the mouse motivated transform is essentially that, but it just moves with the mouse as well. This is really interesting. So the mouse motivated game camera is super interesting because it follows the mouse very closely. And what's cool is I can even set the threshold limit. So the way this works is it finds the position of the mouse and the position of the player. And what it does is that it finds the middle point, but it'll clamp that middle point to a threshold value. So if I set the threshold value to a 5, no matter how far the mouse is, if the middle point is farther than a distance of 5 units from the player, it'll clamp it to 5 units. And I can even set this to like 3, and you'll notice that the mouse, the center of the camera, doesn't stray too far from the player. Now the issue with this is that it moves on like a 1-to-1 ratio, like it moves immediately with the mouse. So whenever you're fighting things, that can be like a little complicated. Like it can get really crazy really fast, and it's almost a little bit nauseous. Especially when I'm like spinning in circles, it can get really nauseous. So that's not my favorite. However, there is one where I use Cinemachine, who effectively do the same thing. The good thing about Cinemachine though is because it handles a lot of the camera stuff on its own. So instead of immediately moving with the mouse, it'll actually kind of lag behind and provide a much more smoother transition. So if I play the Cinemachine camera, you'll see that I can move the mouse, but it doesn't happen immediately. And this gives, like, it can adjust, but like if I'm moving up and down really fast, it doesn't provide that instant jitter. It slows down. It's not as crazy or as convoluted or as hard on the eyes as the other versions used to be. So that's the benefit of that. That's the difference between those. And yeah, so those are all there. I think I'm gonna stick with the Sin Machine, but I do have the prefabs for those set up, so in case I wanted to switch out, or in case I wanted to even make it a setting that the player can choose, I can leave that there. Next, I did the player input handler. Now, I was struggling on this a little bit because I didn't know how I wanted to do this. I originally had the player input handler on a separate object called the data manager. The data manager takes care of like a lot of different like elements of the data, and I'll go into that in a bit more detail in a moment. But I originally had the player input handler on the data manager, but then I kind of realized it was a little stupid, so I just left it on the player input handler, so we're able to use that to work with it. And the player can change a decent amount of scripts, but the input handler essentially, whenever input happens, the input handler reacts accordingly. So we have left click, we have right click, we have left shift, right shift, and it'll react. So what you'll notice is I'm using the old input.get mouse button and all that, which is not the best way to do it. Ideally, I would like to switch to the new Unity input system. However, I'm gonna be fully honest, I don't understand it. It's kind of funky. I've used the Unreal Engine enhanced input action system, which I actually really enjoy that one. I actually really enjoy how that works because it allows you to have different action maps for different levels or different situations, which is really cool. And I think this one functions in a similar way. It's just the wording is a little bit weird, or like there's a different structure to it somewhat. I don't think it'll be too hard to refactor this because I have everything set up in events. So it's purposefully left abstracted just because if I needed to switch to a different input system, I could do that and it shouldn't be too much of a hassle. And yeah, so that was a player input system. Player stats. Okay. So this is where stuff gets a little interesting, and we're going to go over the stuff in the player. So we have set movement speed. Originally, I was going to have the movement speed be determined by the dexterity of the player, the dexterity attribute. However, I figured that would be really irritating because you might not want to move that fast, and it's hard to control that. So unless you have a joystick. So for this one, I just said there's gonna be a set movement. For the dash, however, there is a dash cooldown. The reason that's interesting is because the way the dash cooldown works is if we head over to the dash function, you'll notice that the dash cooldown is determined by the dexterity value of the player. So as the player's dexterity value increases, the dash cooldown will decrease. This is a kind of rudimentary way that I'm doing it. I think in the future, what I'm going to end up doing is I'll either stick with this and just have a kind of like a slide or a bar above the player that indicates whenever their dash cooldown is finished. Or what I will do is I will switch to a stamina system that will show the player how much stamina they have. I think I might have a stamina system because having stamina, I can apply that to multiple things. I can apply that to how many times you can shoot. Maybe you won't regen stamina when you're moving, so you have to stay still. Stuff like that. So I might refactor that in a little bit, but that's essentially how movement works. And there's a couple options for dash. So right now the way dash works is if I press left shift, it'll dash. So dash, cool. Right now it's going with my keyboard, it doesn't matter what direction I'm dashing, but I can enable mouse oriented dashing, which essentially will dash in the direction of the mouse. So I can be walking around and then dash towards the mouse. I will leave this an option for the player to decide because some people might enjoy dashing with their keyboard, some people might enjoy dashing towards their mouse. It's up to the person. And yeah, so that's the movement script. There's a couple more things going on in there, but other than that, nothing else is of too much importance. Again, I use the rigid body system to move. However, for rotation, I get the rotation, I just transformed our rotation. I could use the rigid body rotation. Doing stuff with the rigid body is not a cheap process. It can be quite expensive if you do it a lot. And already I'm moving with rb.velocity. The last thing I want to do is Arby's. The last thing I want to do is add another rigid body function to it, especially when it's not that important. I'm planning on keeping the player's collider as a circle. That's it. It's just gonna be a circle. And if it's a circle, at that point, it doesn't matter what rotation it has when it's bumping into stuff because it's a circle. The rotation of it does not really matter. If I make it a more complex shape where rotation does matter, I can always enable rigid body rotation. But for now, I'd like to run as few expensive proxies. So we're just gonna stick with that for now. Then we have the health script. The health script is interesting. We have obviously max health and current health. And then we have this enumerator called shooter team. Essentially, the shooter team allows for me to decide whether the health script is for the player health or the enemy health. The reason why I have that is because if I have NPCs that are fighting alongside the player, which is a goal, what would happen is the enemies would be able to shoot the NPCs and their bullets would hurt the NPCs, but they wouldn't hurt other enemies. And the NPC bullets will hurt the enemies, but not the player. So that's kind of what I'm going for here. It might be fun to allow bullets to ignore that. Maybe have a setting in the game data manager that allows for friendly fire between enemies and players. That could be fun, but for now, I'm just gonna be using this. It's easy to disable if I need to, but yeah. So we have that on the player, and that's kind of it for the player. It's actually not too much. Start on weapon systems. The weapon system is interesting. We have a couple different things that I can show you. So in the player, we have this object called a weapon. This has the weapon manager, and the weapon manager is quite interesting. So each creature can have 2 weapon slots. You can have a primary weapon slot or a secondary weapon slot. And also there's a Boolean variable that says whether you can fire or not, and also a fire point. A fire point is usually a point, like a transform, that's right in front of the player. And so what will happen is each weapon is a scriptable object. So I can go into here and you'll see that for test primary weapon, it's a ranged object. Its name is test. It's not a melee object, so we don't have to worry about any of the melee stuff. It is ranged, so this is the bullet prefab, this is the bullets per shot, bullet speed, and bullet base fire rate. So all this stuff is different settings. So essentially the way this works is think of the weapon scriptable object as the actual crossbow you're holding, and this bullet is the bullet that you can load into it. What's cool is I can change out the bullet for a different kind of bullet that has different effects. So it's very customizable. You can switch out ammo to different weapons, and you can switch out weapons to different ammo depending on what the weapons do, depending on what the ammo does. So that's the coolest part of that. We also have, if I go here, if I click on the basic bullet, there is a bullet controller. So again, the bullet controller also carries to the shooter team. Essentially, this allows the bullet to check, like if they match teams, do not hurt them. If they don't match teams, then hurt them. So that's kind of how that works. The bullet will take care of damage. So essentially, what it'll do is that whenever it impacts something, it'll go ahead and get the health component. If the health component is valid, it'll go ahead and add the impact and all that. What's cool is that the bullet doesn't last forever, because if it does, that'll be stored in memory forever, and we don't want that. Instead, whenever the bullet is spawned, it does have a bullet lifetime. So right now that's set to like 5 seconds. So after 5 seconds, the bullet will delete itself out of life. Essentially, it's a quite complex weapon system that allows me to change out the weapons as well as change out the bullets. All right, let's see what else I got here. Unbroke my project. Oh, so you'll see commits like this where I'm just losing my mind for a little bit, but yeah. So I'm gonna quickly use this moment to go over how attributes work. The attributes are actually not on the player, they're on the game data manager. And let me kind of explain this one as well, because this one's super interesting. So the game data manager this is a singleton, which means there can only exist one of these, and other components can refer to this component without having a direct reference. As in, I can just type in GameDataManager.instance and just have a reference to this component. That's the use case of singletons. And this singleton just stores data. So it has the player transform, the player game object, the player movement script, the player stat manager, the player rigid body. So any other component can refer to the game data manager and get information from there. So there's never like a null reference error. Information can pass easily, and this singleton, this game data manager, will act as the middleman between that information. Then we have the player stats. So these are all like just max values. This is the player stats scriptable object. And it's gonna get real laggy right now because I'm opening a scriptable object inside a scriptable object. But essentially, this player stats carries strength, dexterity, endurance, constitution, intelligence, and mana. And they'll all be used for different things. So these are all integer variables as well. So essentially what that means is because they are not variables that live in the script, but they are scriptable objects that contain data that live in the assets folder, I can effectively save and load these, and the numbers will stay consistent between scenes because they're loading from a object in the assets instead of a data value that is stored in memory and closed from the memory whenever it goes to a different scene. And this is a timer. This is a little interesting. This will keep track of the number of days that have currently passed. Time is an somewhat important factor, as you can see, like, because daytime has different properties, nighttime has different properties, so this is what will keep track of that. This will keep track of the time currently and all that. In fact, if I play it, the time actually moves. Yeah, you'll see that it's counting, and then so right now it is night, and then pretty soon it'll switch to day whenever it hits like 300 or something. But yeah, so it's 23:54, and now it'll be daytime whenever it hits 6 a.m. And boom, there we go. So number of days is 1, and it actually updates it right here. So yeah, now we're gonna get to my favorite part, which is enemies. I love working on the enemies. The AI is really fun. So I have a couple things here. One, I have the basic melee enemy. You'll see a couple circles around them. The weapon, so this is a dodge trigger, and I'll explain why that is important in a moment. This is stop range. So this is when the enemy will stop when it gets close to the player. I'll set this to 1.5, but essentially you'll see that this melee enemy will chase me, and they'll come after me and all that. What's cool is I can enable different settings. So the enemy can dodge, and they have stamina, which means they can't dodge all the time, but they absolutely can dodge. So this took a long time to figure out, but the enemy can dodge my bullets. So effectively, I can shoot a bullet at him, and he'll be able to dodge. And what's happening is that if a bullet enters this green circle, this trigger, the enemy will detect that bullet, and it'll go ahead and see if the bullet's to the left or right, and whichever direction it is, it'll move in the opposite direction. I can disable the dodge, which means that it'll just run towards me. It won't really, do nothing else. Oh, why is dodge on? So now, ideally, this should work. So now the enemy should not be able to dodge. Yeah. So I can disable and enable dodge whenever I like, and then if I want him to dodge, I can have him be able to dodge, and I can set his stamina. I can set all that stuff. So yeah, awesome. So yeah, that's the basic melee, and the dodging feature makes him super cool. And now we get to the ranged enemy, which is my favorite. So the ranged enemy is super interesting because it uses the exact same movement scheme. I'm gonna disable dodge for now, but what's fun about the enemy, or the ranged enemy, is that this right here, enable aim leading. Aim leading is when you have the enemy take the player velocity into consideration, along with their bullet speed, and what it'll do is it'll calculate. It won't just shoot at the player, so the bullets, as the player's moving, the bullets go behind the player. It'll calculate where the player's going and at what position the bullet and the player will collide. So right now I'm just going, but you'll see that as I'm moving, the enemy will switch to a rotation, and then you'll see that if I'm moving, the bullet will go towards the player regardless of what direction the player might be moving. And the ranged enemy won't shoot until the player's within a certain range, but essentially if I'm right here and I just keep moving to the left, it'll hit me. The bullet will hit me. So it'll calculate, and it'll be smart enough to move its aim direction forward to accommodate for the player's movement, which is super fun. I can also turn this off, so basically what'll happen is it won't lead its aim, it'll just shoot behind me, and you see the bullets just keep kind of going behind. They never actually hit me because I can just run circles around it. And that's the benefit of aim leading, where even if I run circles, it'll calculate and it'll accommodate for that. So I can't just cheese it by going, whoa, you can't hit me, because it will hit me every single time. And what's cool is, since they all use the same follow object script, I can essentially have any combination of this. I can have the GameDataManager or enemy spawner determine if the enemy can dodge, or if it can aim lead, or if it can do both. So now we get to the interesting part, which is weapons. So how do these enemies determine what weapon they use? And they also have a weapon empty object, which has its own weapon manager. but you have this other script called an attack base. The way the attack base works is that whenever the enemy is in range, you'll see that the follow object script has two events, an in-range event and an out-of-range event. So for an in-range, this references the attack base, and I called it an attack base because originally I was going to inherit from it, but then I realized it can do multiple things, so why even bother having multiple children of it? I just use the base class. But essentially what attack base does is that it'll give it an interval, so it can't attack continuously, and it'll even keep track of if is it attacking or not. This references a weapon manager, which is the exact same class the player has, so even the enemies can have their own weapons with their own bullets, and their own melee weapons, their own ranged weapons with their own ranged bullets, and I can even switch it out. It basically adds a crazy level of complexity and uniqueness to a system, and it's very easy to implement because the player and the enemies use the exact same system. The NPCs as well, just give them different transforms to worry about, and then we're good. We're golden. I can have melee NPCs, I can have ranged NPCs. It's just a super fun way of adding extra depth to the game without having to program a billion different things at once. So I'm super proud of how this system came together, and yeah. So yeah, that is the update. That's what I have for right now. I'm quite happy with how the game is shaping up. There are a couple things that I want to discuss. Number one, I'm sure it's obvious. I believe I mentioned this before, but if I haven't, I think it's a good time to talk about it. I am using Unity. I know Unity has had some controversies recently, and I am not blind to them. I do understand that with using Unity comes with a risk. However, I am using version 2021.3.21, so the benefit of that is that I don't believe the new runtime fee applies to me, because one, I don't even know if I'm going to release this game for a price. This game might just be a free game. However, the more I think about it, the amount of effort that I'm putting into it, if I can get the game to look well, art-wise, and have a decent art direction and a good art style, and I decide to put it up for a fee, even if the runtime fee applies to me, if it's sent on a certain paycheck. So if I set the game up to be $5, the runtime fee will be not $5. It'll be significantly less, perhaps a few cents or something like that. I do understand the controversy. I do understand that it's an issue, and please don't get me wrong, I think the runtime fee is a really stupid idea. I think it all started because Unity bought Weta, and now whatever they're doing with Weta is they just made some bad decisions. The reason why I'm sticking with Unity is, one, if I release this game for free, I don't think the runtime fee will impact me in any way. And if I don't release it for free, I still don't think the runtime fee will deter me from working on the game. But more than that, I am also very comfortable with Unity. I've used Unity for many, many years, and I'm quite comfortable with how Unity handles its flow of information. We recently switched to Unreal in college, and learning Unreal has been super fun. I really do enjoy working in Unreal. What's interesting about Unreal is that the flow of information is quite different. Or not flow of information, but I will say the way you go about making something is quite different. In Unreal, you use whatever pre-made class is there, and you can either inherit off of it to make your own class to add some extra features, or you can edit that class directly and remove some features, or just not use some features. However, for Unity, you make everything from scratch, and each version has its own benefits. I'm using Unity because, one, Unreal's 2D systems are a bit iffy. I do plan on using Unreal for other games in the future, but for this, since it is a 2D game, I'm comfortable using Unity. My plan for this is to make a VR version, a top-down version, and a first-person or slash third-person version. For the first-person slash third-person, I will for sure be using Unreal. There's really no better way about it. Unreal has a very, very well-made first-person and third-person controller that I can just use and add on to. But Unity is well-suited for 2D games as well as even VR games, if we're being honest. Unity is kind of the king of VR right now. So yeah, that's gonna work. I am looking into Godot. I am learning Godot. There's interesting. I actually really enjoyed the node system that they have there. I think it's a really cool way of saving objects. Very modular, which I really enjoy. But yeah, so that's kind of it. I'll check in with you guys in a bit later. Yeah. Okay, bye.